All right, grade 8s, this is our last math lesson that we're doing with algebra and geometry. It's mostly geometry, but definitely today there's a lot of algebra put into it. And what we want you to know is that for these questions we're going to do today is the geometric proofs that we've been doing still apply. You still have to name which proof that you used, and then use a little bit of algebra to figure it out. So if you're looking at this first example here, um, and it's two angles, and it looks like a straight line with two angles in it. And the angles are EFH, which is here, and HFG. And that's important too because we haven't done a ton of work naming angles that way. We've been just using angle X or variable C in the middle of a question. But now for these questions, we will have to use our vertex in the middle when we're naming. So let me show you what I mean about that. I'll move this down here. Get rid of that. So what I mean is, if I wanted to do this angle later that had 3x in it, the one on the right, the angle that I would name it is angle HFG. I could have also called it angle GFH, and it only matters that the vertex, the letter in the middle of the angle, is presented in the middle of your naming of that angle, and then I know exactly which one you're talking about. Anyhow, when we're looking at this one right here, you can see that there are two angles that we don't know, and they're labeled with variables, 6x and 3x, but we know that that's a straight line, and we know that straight lines equal 180 degrees. So basically, we know that 6x plus 3x is going to equal 180. We know that because that's our supplementary angle theory that we've done a ton of. And we see 6x and 3x, and there's no reason to leave them like that. We're going to collect those terms, and 6x plus 3x is 9x, and that equals 180 degrees. Now, we don't want to know what 9x equals. We want to know what 1x equals. In order to do that, we have to isolate. To isolate that variable, we have to leave it by itself. We do that by doing the opposite operation to both sides. So I'm going to divide both sides by 9. What I'll have remaining is x, and x equals 20 degrees, and that's really good. And that's supplementary angle theory, so we include our proof. But that doesn't help us actually figure out what angle HFG is yet. But now that we do it, we know that HFG is equal to 3x. And we know that x is equal to 20, so what we're just going to do is substitute the number that we got from our equation, which is 20, into our variable. And 3 times 20 is 60. So we know that angle HFG is equal to 60 degrees. And there's one more to do because angle EFH, which is the other one, is equal to 6x. And again, we know that 6x is 6 times 20, because we know that 20 is what we solved over here. And 6 times 20 is 120. So angle EFH is equal to 120 degrees. And that makes sense because 120 plus 60 is 180 degrees. So that's how we'd solve this first one that's complementary. Okay, so now if we were going to do example 2 here, example 2 has a triangle. Now we have to start saying, okay, what triangle theories do we know? And of course we know from many examples that the interior of a triangle is going to be equal to 180. So we're going to do the same thing here. We're going to take all of the information that we know. So we know that one angle is represented by 4x. We know one angle is represented by 3x. And we know the last angle is represented by 10x. And we know that all of our angles in a triangle equals 180 degrees. We've done it enough that that's not the problem. We have to collect our terms. There's 4x there and 3x there and 10x. We put them all together, and that's 17x equals 180 degrees. Now, when I was making these questions, I did not take care to make sure that they were absolutely to scale, and so some of the numbers will be decimal numbers, and they won't quite be right if you were to put a protractor on it, but the process is right. So don't don't get too worked up if when you measure these at the end they don't quite work out, because I was just giving you some examples. So again, we have 17x equals 180. We want to just know x, so we have to isolate the variable. In order to do that, we have to do the opposite operation. So 17 times x, we're going to divide it by both sides. And x is going to equal 10.5888. I'm just going to make it nice and easy, 10.6. I rounded my answer. So I know that x now is equal to 10.6. But I have three angles inside this triangle that we will have to determine. And remember, when we are naming an angle, we keep the vertex to the middle. So let's start with this 10x right here. The angle would be angle ABC. Angle ABC. Our vertex is in the middle. And we know that that is equal to 10x. And we know we simply just substitute the x that we've already found, which was 10.6. And hopefully you know that when we multiply something by a base 10 number, you just move the decimal over. So this is a very quick answer. It's 106 degrees. And that's our first one. Our second one, let's say we do this 3x here. That we can show by going angle BCA, because remember we keep our vertex, our middle, in the middle of our name. And we said that that was going to be 3x, so that's what our picture showed us. We substitute the number that we already solved, 10.6. And doing this one, we can see it's going to be 31.8 degrees. And that's our second one. And then all we have is one left, this 4x right here. And if we leave the A in the middle when we name it, we can call it angle BAC. It equals 4x. We substitute in the number that we figured it out to be, which is 10.6. And when we're done, we get 42.4 degrees. And there's our three angles inside of our triangle. And you know what? We forgot right up here, it's a really important point. You have to put your proof. And we knew that this was going to work because of interior of a triangle. That's so important. I almost forgot to put our proof. Anyhow, we have one left. And that is going to be, let's try a complementary one. All right, so here's our new angle. We'll call it X, Y, Z, and W. And we can see that it's a 90-degree angle, and we know our 90-degree angle is going to be our complementary angle theory. But anyhow, we see 7x and 2x, and we don't actually know what those are. Those are variables taking the place. So we'll put our 7x plus 2x, and we know that a right angle equals 90 degrees. So we collect our terms. 7x plus 2x is simply 9x's, and that equals 90. Now I don't want to know what 9x equals, I want to know what 9 is. To do that, we have to isolate x. We have to get rid of the 9. We do the opposite operation on both sides, which is division, because the 9 was multiplying x. And x is equal to 10. And again, we got that using comp. Please don't be worried that if you get this and you get a decimal answer, just round it and it'll all be fine. Anyhow, so now we have two angles we got to figure out. We'll figure out our first one, but therefore, angle XYW, and we know it's equal to 7x. We substitute the answer that we found out over here on the right, because 1x is 10, and 7 times 10 is going to be 70 degrees. And lastly then, the other angle we don't know is angle WYZ, being very careful to leave the letter in the middle, your vertex, in the middle of your naming of the angle. So we know that this is equal to 2x. X is equal to 10, so we just simply substitute the answer that we put in. We use brackets to show substitution. And that's going to be 20 degrees. And that makes absolute sense, because 20 and 70, that's 90, and you know that's what a complementary angle is. Anyhow, guys, this is the basis. This is the last thing we have to do. All the questions you can get are pretty darn similar to the ones that the three that I just showed. including the 3 that are on your test prep that I gave today in class. And that's posted. Take a look at it, play around with it, be confident with it, and ask any questions you have. Thank you.